All right, another use of biotechnology is in solving crimes. And the first time that biotechnology and DNA was actually used in court was in 1987 in a case where a gentleman named Colin Pitchfork had attacked and raped and murdered two 15-year-old girls. Not at the same time, they were a month or two apart, but it was in the same area. And this was a very interesting case because initially the police had a different suspect and had actually arrested a different person in relation to the crime, a young man from that area, and he had confessed. He had been interrogated by police for 30-some hours, and he finally confessed to the crime, so they thought they had their man in custody. But because there were a few inconsistencies, one of the investigators went to a local college where DNA research was being done and said, well, hey, could we test the DNA from this crime scene? It was a very violent murder of both the gals, so they had lots and lots of blood from this crime scene. What they did then, the police went to the community because based on evidence at the crime scene, they knew that these two crimes had to have been committed by the same individual. In fact, they did the DNA analysis to prove that it was the same person, they just didn't know who, and that it was most likely somebody local, somebody in the area, and had to be a man between the ages of 18 and 35 years old. So the police went to the community, and this was a small town, and everybody was so horrified by this brutal rape and murder of two young girls that everybody knew that they were more than willing to help, because the investigators went to the community and said, hey, could every man in this community come forward and submit your DNA voluntarily so we could eliminate as many people as possible from our pool of suspects. We just want to get as many people eliminated as possible. They collected over 5,000 samples from the population, and one gentleman, Colin Pitchfork, the police had a sample on file with his name on it. However, he was apparently at a bar bragging or talking with somebody and was overheard that he didn't submit his DNA. He had a buddy a couple of towns over turn in DNA for him instead because he thought that was ridiculous. Well, that got back to the police. Somebody let the police know that, hey, this Colin fellow was just, talking at the bar and this is what he was saying. So the police went to him and said, hey, Colin, we're sorry, but can we please get a sample and test it again? And he voluntarily gave a sample again to the police, and they took it from him directly and ran it through the analysis, and it was a perfect match. So it was actually this Colin fellow who had committed these brutal, brutal crimes, and he's still in prison for that. That was the first time DNA was used in court. DNA fingerprinting relies on something called a variable number of tandem repeats, so VNTRs. And variable number of tandem repeats basically are areas in your genome where you might get a different number of repeating sections from mom and dad. So up here at the top in purple, this is individual A. It may be a chromosome that came from mom originally, so this top line represents one chromosome. This bottom line is a matching chromosome from dad. Maybe mom's region in here gave you more copies of this repeating section than dad's. And on a separate chromosome, a separate location, again, chromosomes from mom and dad, those homologous chromosomes, maybe mom gave you fewer copies than dad did. So what you do is use restriction enzymes. Remember, those are specific, so we can pick restriction enzymes that will cut right at the ends of these repeating units, and we can cut out those differently sized fragments. And that's what we've done with our DNA analysis in lab, is we've cut out those different fragments. One or two is not going to be enough to identify a suspect, so usually about 10 different locations across the chromosome are used. And in fact, FBI maintains a database called CODIS, and here's the website that has kind of information for the public. CODIS stands for Combined DNA Index System, and anybody who has been convicted of a crime, or in some cases arrested, or the suspect of a crime, depending on the state that you're from, there are different laws regulating who gets entered into the CODIS system. But they take your DNA and put it in there. Then anybody across all 50 states, and we're working with other countries to kind of make it uniform so that it can even go across through different countries, you could put their information in there and CODIS system could give you matches. So tell you whose DNA that is that you have. So it's based on these short tandem repeats. And this shows the 13 CODIS regions that are standard. So there's a location on chromosome 2, 3, several on chromosome 4, 6, and 7. 11 and 12 have a location, chromosome 13, 16, 18, 21, and even the X and Y chromosome have separate locations so they can determine the gender of their suspect. So with a combination of about 10 of these, we can get a guaranteed match. And if there's some question, if two people have very similar CODIS markers, then you can add the other 3 to get all 13 CODIS markers if necessary. Limitations of DNA. It can't establish guilt, only tell you who could have been involved. Kind of a very generic example. Say I'm walking down some dark alley and I trip and I fall and scrape my knee across the pavement. I get up and limp away thinking, oh, that really, really hurts. What am I going to leave behind? I'm going to leave behind my blood and my skin cells scraped across the pavement, right? What if on that exact same spot, a few minutes later, somebody gets murdered and killed right there where I tripped and fell? Well, the police are going to come and process the crime scene, and they're very thorough, so they collect all blood and everything that they find. They're going to find my DNA all over their crime scene, smeared across the pavement, right where they found the body. Did I kill anybody? Well, gosh, I hope not. So even though my DNA is at the crime scene, that doesn't mean I'm actually guilty. I might know something about it. Maybe I saw something or heard something. And so I might be able to help the case, but DNA alone doesn't establish guilt, unless it's perhaps a rape case, and then the DNA is pretty definitive. There's only one way it got in there. So other things to keep in mind with DNA, it remains stable for years. Very stable stuff. We've already mentioned that the oldest DNA we've extracted was from a Neanderthal 30,000 years ago. And so DNA from a couple decades ago, sitting in a case file in some shelf somewhere, that's still very easy to go back and test. There are no false positives, so if we test your DNA, even if it's broken down a little bit over time, it's not going to accidentally match somebody else's profile because it broke down. The only thing that happens if DNA does start to break down is it limits the usefulness. You do the test and you learn nothing. That's it. So DNA is very, very reliable in court cases. The power of DNA. If you do all 13 CODIS markers, the probability of a match is 1 in over a quadrillion. That has 15 zeros on it. And that number exceeds the total number of people who have lived on Earth ever since the beginning of humankind. So, the possibility that somebody else having the exact same CODIS profile of you is pretty slim, unless you're an identical twin. Identical twins, because they come from the same sperm cell and egg cell that combined into one zygote and then later split into 2 separate people. Because of that, they are a natural clone. So they have the exact same DNA. So if you're an identical twin and they commit a crime, your DNA is always going to match perfectly. To give you a little bit better idea of what a quadrillion looks like, here is a cube of a trillion pennies next to some common buildings, so the Sears Tower, Empire State, Washington Monument, Lincoln Memorial, and a football field. So that's a trillion pennies. If we stack up a quadrillion pennies, it dwarfs those skyscrapers. So the probability that anybody else matching your DNA using all 13 CODIS markers is one single penny in that whole stack. So 1 in a quadrillion are going to match. So highly, highly, highly unlikely. Alright, so that's the end of Chapter 5. We've already covered Chapter 7. So exam 2 will be approximately 70 points. There'll be 10 points of review material from exam 1, and then 60 points of new material. There'll be about 40 to 50 points of multiple choice and 10 to 20 points of short answer.